thank you for letting these, whatever we want to say that. But you can't really go beyond that now. Okay? Okay.
Anybody like some refreshments? There's fresh coffee made back there.
Yeah.
We're actually trying some new coffee. We got a fair trade coffee in, so if anybody would like to try it, would like to try yourself a cup.
I think everyone's a judge.
No, not everybody's judging. Actually, it's only Chloe, Zoe, Maya, Mrs. Nigveski, and Mrs. Macaron are judges. Everybody else is your audience, and they can listen, and they will be allowed to give feedback at the end and ask questions, but they're not actually going to be ranking you guys. Okay.
So, but I also have Abby on the other team, so that's equal.
Yeah, it's like, technically we're in your team. It's like Joe Biden voting for your sister probably would be that.
Before everybody gets started, I just want to thank everybody for coming today. I know Pastor Brett's going to stand up and do some official announcements, but I want to thank everybody for coming and listening to this. These kids have been working really hard on this debate for the last about over a month now, trying to prepare for it. And they're looking at the big debate that really we face in the world today, is that the secular world has basically is trying to prove that that we can prove exactly how we got to now without any influence, any factor of God. And so we realize that as Christians we go out and face this all the time. And so what we had to do in preparing this debate, what I challenged the kids to do, was to take the two opposite sides. So just to give you background on how it works, we decided there's an affirmative team and a negative team. The affirmative team, which will be on this side actually, had to prove, they're trying to prove that evolution basically is the only explanation for how we got to now, that God is not a factor in any of it. And then the other team's job is to basically try and break that apart. Understanding this though, that we're all Christians, so for those of you who are concerned that we've got heathens in the room or something, it's not like that. It's we all have an understanding that God is our great creator and all of this. But it's important that they understand how the debate is going on out there in the world, so that when they go out, their opinions actually might be, I know with some of them, their opinions are somewhere in between. They believe in some aspects of evolution, and it's definitely the aspect of a creator. But the fact is that they really, they have to present the two opposite sides and extremes here, so that they can do this as an academic exercise and understand what the extremes are. So just understand that as you go into this. And they're also only limited to 6 minutes to speak, tops, each per person. We're trying to make this a very formal debate style like they would do in high schools and colleges, so they know what it's like to actually perform a debate. So we really appreciate you guys coming in as an audience to listen to this, and hopefully you'll get something out of it too in listening to it, but we appreciate them having to present in front of you people so that they know what the experience is like. I just want to say that before Pastor Breck is up to give his presentation.
Well, my wife covered most of what I was going to say.
You can say it online though. You say it online now though.
It is online.
Oh, whoops.
That's all right. Yes, thank you all for coming and providing the voices, the votes, the added stress for our students that they need to learn how to perform under pressure. We have, I know, represented amongst our debaters, we have Darwinian evolutionists, we have young Earth creationists, we have old Earth creationists, and they're not necessarily representing the positions they actually believe. So this really has been a exercise in learning to really understand the person you're disagreeing with. Because as Thomas Hobbes said, genuine disagreement is a real achievement, because most people don't listen to each other long enough to know whether they disagree. They just start arguing. So as they come forward, we have a presenting side, we have a rebuttal side, and everything's going to be in a standard format. So encourage you to watch and be edified, and welcome to those of you who are joining us online, which is probably Amanda and Elias, you guys. So it's not that big a deal. There's people who are normally in the room with us anyway, so it's all good. All right. So Lisa, I'll let you just take over and you call the ball.
Okay. So the first speaker up will be the affirmative side, which is arguing in favor of evolution. So you can begin.
Okay. Hi, I am Matteo Macaron. Thank you all for coming out to our evolution versus creation debate. I am on the evolution side, here to tell you that evolution without divine intervention is the only possible explanation for life today. But what is evolution? Evolution is the idea that through means of natural selection and mutation, organisms can go through major changes and allow for complexity and diversity of life today. Gerald will be talking about the geological column. Elizabeth will be talking about abiogenesis and mutation. And Gerald will actually step back in to be our rebuttal. And I will be talking about the fossil record. Okay. Now let's start with, what is a fossil? A fossil is the preserved remains or traces of any organism from the past. Now I'm going to tell you about the succession of fossils. These fossils are dated by knowing the age of the rock layer. So sedimentary rock layers, they develop in a chronological order, meaning the lower layers are older than the newer layers formed on the top. In other words, each layer represents a length of time. Transitional fossils. Creationists may believe that all life is connected in like a chain or a ladder, a nice neat line of progression. But evolution is neither a ladder or a chain. Rather, everything is like a blended mess. A cloudy soup of organisms that share or do not share certain traits at different junctures. Here are some structural changes from ape to human. Structural change. More downward facing foramen magnum, S-shaped curvature, longer leg arm ratio. These mean walking upright without the use of hands. Shift in position of gluteal muscles. The evolutionary advantage for this is hands available for the tool manipulation. Larger heel bone and a ligament alignment of big toe increases weight bearing on lower limbs. Marked reduction in body hair. The evolutionary advantage for this reflects use of fur clothing from hunting. Lower and broader pelvis reflects use, lower and broader pelvis is the evolutionary advantage of altered birthing patterns for larger infants. Smaller teeth and narrower jaw is the changed dietary requirements, meaning more meat. And increased average height is the consequence of improved diet. Now, knowing these fossils is really important, but knowing the age of these fossils are actually more, I would say, more important. So this leads us to radiometric dating. Radiometric dating is the method that is based on creating a comparison between the observed abundance of naturally occurring radioactive isotope and its decay products. Also using known decay rates. Radiometric dating is a very accurate method that proves the date of the world is 4.5 billion years old. This is very important because many creationists argue that evolution could not have happened because the Earth is 6,000 years old, which it is not. This brings us back to evolution. Evolution without divine intervention is the only reasonable explanation for life today. Thank you.
Okay, the next speaker will be Polly Macaron.
Good morning, everyone. My name is Paulie Macaron, and we believe that we couldn't have got here without a creator, which is God. I'm going to be rebuttaling Mateo. First off, I'd like to say that we do not believe that the Earth is only 6,000 years old. We are actually older creationists. We believe that it still has been billions of years or millions through the Earth. And a question I just want to ask: if you believed in neo-Darwinism or punctuated equilibrium. Sorry. That's what I have for my rebuttal. And if they want to bring something up for me, okay. So I will be going first for our team. As you can see, I will be talking about molecular biology. We will be having Pietro go second. He will be talking about irreducible complexity. Next, we'll be having Addie go for us. She will be talking about proteins. And lastly, Ian will be our rebuttal. What is molecular biology? Molecular biology is the branch of biology that deals with the structure and function of proteins and nucleic acids that are essential for life. What is the most important type of molecule in the chemistry of life? The protein. There are certain proteins that are common to many species. Most organisms have the protein cytochrome C, which takes part in the cellular metabolism. So, the cytochrome C that you find in bacterium is a bit different from the cytochrome C that you find in humans. Amino acids within a protein determines its structure and function. Thus, if you were to examine the amino acids, the cytochrome C of different species, you'd find slightly different sequences. What does that tell us? Well, proteins are made in the cell. Thus, by looking at amino acid sequences in protein, you're actually looking at the differences between the specific parts of those organisms' genetic code. Genetic code is the part that determines the makeup of this protein. As you can see here, what Ian is holding up for me, the data is telling us the percentages of the cytochrome C in an animal compared to other organisms. As you can see, first, the cytochrome C compared to lamprey eel. Second, the cytochrome C of a carp compared to other organisms. Then a pigeon, and lastly a horse. Now think about what this data tells us. We are comparing the cytochrome C of a mammal, a bird, a reptile, a fish, and an eel. According to macroevolution, eels would have come first. Later, fish would have evolved. After that, amphibians would have evolved, followed by reptiles, followed by birds, then finally followed by horses. Thus, the eel should be the most similar to the fish, then the reptile, and then the bird. It should have the least common with the horse. Instead, the data tells us that the cytochrome C in the lamprey eel is most like the carp, but then most like the horse, and essentially the same differences between the turtle and the pigeon. If you look at the data, it is clear you can establish no macroevolutionary trends. If you map out an amino acid sequence of virtually any protein and compare them to other organisms that have the same protein, there's virtually, you'll generally find no macroevolutionary trends. Instead, each kind of organism seems to be equally or equally different. Equally or be nearly equally different from every other organism. Again, it seems to be equally or nearly equally different from other kind of organisms. In conclusion, molecular biology proves that because there is no connection between the complexity of the animal and the similarity of its DNA to other animals of similar complexity, that is impossible for the animal to have evolved. Thank you.
Hello, I am Gerald McVesky, and today I will be arguing on the side of pro-evolution and reaffirming the statement that evolution without divine intervention is the only reasonable explanation for life today. I would first like to begin by rebutting Polly. First of all, we do not believe in neo-Darwinism or punctuated equilibrium. We're not using either of those. And second, with your statement about, what was the name of the acid that you said? Cytochrome C. Although that's found at different rates in different animals, and it doesn't seem very consistent, that is a single amino acid that they're finding. So just because it does not follow it just in that one amino acid doesn't mean they don't line up in other respects. So next, I will be speaking to you a bit about the geological column and how that helps prove evolution. So first of all, what is the geological column? The geological column is a diagram used to describe the layers of rock and strata formed on the Earth. As Matteo previously explained, they started out at the bottom and then built up slowly over the years, encasing fossils within them. Now because of this, we are able to figure out that the rocks on the bottom are home to the oldest fossils, and the rocks at the top are the newest fossils. Thus, we can create a diagram that illustrates the chronological progression of species. Now, the geological column is split up into four main groups: the Precambrian, the Paleozoic, the Mesozoic, and the Cenozoic. The Precambrian is home to very simple fossils such as this stromatolite. It's clear when looking at it that it's very simple. It actually looks very rock-like because it is mostly formed from sediments from the Earth. The way it doesn't yet have complex organs to complete vital functions that we might have today. Instead, it uses simple processes like absorbing water from the ocean and getting nutrients from them. So this is the first organism, which is very, very simple. Next, we move on to the Paleozoic era. So the Paleozoic, we get slightly more complex organisms, such as the trilobite. Now, trilobites, although they still lack the necessary organs that we have today, they are still far more complex than the stromatolite. In fact, by looking at them, you can already tell from one era to the next, the complexity has certainly increased. Now, why is it important that the complexity is increasing? Well, one of the main definitions of evolution is that they grow in complexity. So, because we can observe, knowing this is in chronological order, the progression of complexity, it supports the idea of evolution. Next, in the Mesozoic era, we have dinosaurs, such as the T-Rex, which I have here. Now, this T-Rex skull alone is far more complicated than both of the trilobite and the stromatolite combined. In addition, the sizes have grown significantly. This trilobite is nearly to scale. I believe it's at about 75%. But this T-Rex skull is obviously not quite to scale. A T-Rex skull would be approximately the size of a bathtub. And yeah, quite obviously it's a lot bigger than this. But now that we can see, once again, going back to the chronological order, we know that over the years it has progressed not only in complexity, but is grown in size as well. And in the dinosaur, we also begin to see complex vital organs that we do have today, such as the heart, the lungs, the pancreas, etc. Finally, we move on to the Cenozoic era, where we are introduced to fossils like the woolly mammoth, the Neanderthal, and the lion. Now, they have not changed too much in complexity when compared to the Mesozoic era, because all of the vital organs are quite similar. There aren't too many changes, but we do see a big change in diversity, which is the second definition of evolution. So you can see here that this woolly mammoth looks nothing like this Neanderthal, and this lion looks absolutely nothing like this woolly mammoth. So here we begin to see, just in a short progression, we're able to see increase in complexity as well. So now, because we know that these are all in chronological order, we are able to make a really good illustration of how they have progressed. And just you looking at it with the naked eye, not even looking at the biology in it, we can clearly see that they have progressed in complexity and diversity, which once again supports the idea of evolution. And thus, by examining the column, it is clear that evolution without divine intervention is the only reasonable explanation for life today.
Oops. Whatever. Good morrow, everyone. My name is Pietro Macaron. I am on the side of creationism, and we believe that we got here today through intelligent design by God. Now, first to go off of what Gerald, I'll be rebuttaling what Gerald said first. There's actually a period right here called the Precambrian period. This is the Precambrian period. This is the Cambrian period. The Cambrian period is a very small period throughout this whole process, because this is probably one of the longest periods there are. And this right here, they went from this to this in a very short period of time. And if we were to, an illustration of this is, if we were to put this on a 24-hour clock, this right here, and this were to be placed on a clock, it'd be like maybe 2 minutes or an hour compared to this whole time right here, which is impossible. And these three or more phyla from this period to this period appeared basically out of nowhere, from this rock to basically every phyla we have. And phyla is just the it's basically how you can tell the difference from a whale to a starfish. And also there's a trilobite one. Almost, yeah. So, besides that, I'm going to start my speech now. I'm going to be talking about irreducible complexity and the flagellum. Irreducible complexity is the argument that certain biological systems could not have evolved by small successive modifications through pre-existing functional systems throughout natural selection. That's a lot to handle, but basically, it's a system that is so complex and simple at the same time, it had to be created, and that it could not have evolved, even through natural selection. An example of irreducible complexity is the mousetrap right there.
Moderator, can that be brought forward closer to the speaker? Is that okay?
Yes, that's fine. Mm-hmm.
Okay.
The mousetrap has the hammer, the spring, the holding bar, the platform, the catch. Now, if any of these parts right here were missing, the whole machine would break down, and you wouldn't be able to use it. Like if the platform is missing, you're not catching any mouse. And an example of something that is irreducibly complex, or something we know is irreducibly complex, is the flagellum. The flagellum is a microscopic bacterial thread-like motor. It would be attached to the back of a bacteria or any single-celled organisms, and it would allow them to swim by propelling it. So it'd be behind them and propel it like an actual motor on the back of a speedboat, except for it's like microscopic. And these are not rare to find. These are basically on any single-celled organisms. You can find these anywhere. And the flagellum is actually in something called a molecular machine. This machine is one of the most simple yet efficient motors ever. It is actual outboard motor, and it is more efficient than any outboard motor that's ever been created by humans. And people claim it got its parts from other molecular machines, but there are parts in the flagellum that have never been seen in any other creature. To quote Charles Darwin in The Origin of Species, if it could be demonstrated that any complex organ existed that could not have possibly been formed by numerous successive slight modifications, my theory would absolutely break down. The flagellum is the perfect motor, and like the mousetrap, if one part was missing, the whole machine would break down. And that's the problem, because it basically could not possibly have made it to here through natural selection, because there are way too many. The odds are only 1 in 21,000 that the evolution would be beneficial to the flagellum, and that's a lot, and the odds are just not in favor for evolutionists. And every part is just so intricate and complex, as you can see right here and right here, that it's just crazy to believe that it just happened all by coincidence. And don't forget, if any of these was messed up or missing, the whole entire machine would not work. See, life is just so complicated and complex that there has to be a creator or an intelligent designer, and we believe that intelligent designer is God. Thank you.
Hello there, I am Elizabeth Jenkins. Thank you for having me out here today to discuss the debate between evolution and creation. I would like to begin by briefly rebutting the points made by the opposing team. Now, as Pietro said in his speech, in his rebuttal specifically, there is a time between the Precambrian and Cambrian era that if the whole time that life on Earth had existed were put onto a clock would be about 2 minutes of time. Now, the difference is that that's talking about time as we think of it. This is referring to geological time. And that time is thousands or even millions of years. Although it seems like a very short span of time, it actually is quite a long span. And on the idea of there being the fact that these things could not have just developed randomly, think about what something like a nuclear meltdown could do to mutate a creature beyond recognition almost. We have things like Siamese twins where there are two people, like two separate heads on the same person. And I don't know where to go from this. And now I would like to move on to my own speech. And I would like to prove that evolution without divine intervention is the only reasonable explanation for life today. And what creationists are willing to believe and to persuade others to believe is the idea that the world was simply created by some deity several million or billion years ago. But we evolutionists are not convinced by such a simple concept in the creation of some deity to explain away something that is so hard to explain. We instead propose the natural and observable means of abiogenesis. Now, what is abiogenesis, one might ask? Abiogenesis is the idea that through natural chemical processes, life began on Earth. And how could this happen? Let me take you back 3.9 billion years to the beginning of life on Earth. Now, back in this time, there were violent storms and volcanoes erupting all the time because the Earth was still settling after its initial formation. Molecules were colliding into each other in what could best be described as a primordial soup. As ash settles onto this primordial soup, suddenly there's a flash of lightning, and the first amino acids are born. Now this sounds like something out of some science fiction story, something that could never be truly recreated, but it can be recreated, and it has been recreated. Specifically in a lab by Jeffrey Botta back in 2008. In his experiment, he used purely natural substances that would have been common at the beginning of Earth's time, including ones that would have been common in volcanic ash and volcanic gases, like sulfur. He zapped it with a spark of electricity, and when he came back, he found not 1, not 10, but 22 amino acids. And amino acids are the building blocks of proteins, which are the building blocks for all life. And if you think that creatures could not survive within such a harsh environment, simply go out to Yellowstone National Park in Wyoming, and you will smell the sulfur in the air that would have been common at that time. And you are practically choked with it, and yet you go and you look at the pools, and you see that they are teeming with life to the extent that they have changed the color of the water. And how do we get from such simple organisms to the diversity and complexity of life that we see today? That is through two processes: natural selection and mutation. Now, natural selection is a very simple concept. It is the idea that creatures kill other creatures for the sake of survival. Survival of the fittest. It's a cruel concept and a harsh concept, but it is one that we can see today. If there were truly a loving God, could there be such a harsh reality? Evolutionists believe not. We believe that the way that the natural selection is used is to work through mutation, specifically through one particular type of mutation called germline mutation, which occurs within the gametes, which allows creatures to reproduce. And one thing to keep in mind with mutation is that beneficial mutations become more common with natural selection, whereas creatures without the beneficial mutation or with a harmful mutation instead get edited out. And the best way to see this is with the coronavirus, which has been around for only 1 year, but already has had 1 million different variations that are appearing practically every other week because of the fact that it is steadily mutating to avoid its destruction. And if that's not evidence for evolution, I don't know what is.
Hi everyone, I'm Addison Isley, and I'm on the side of creation, arguing that we could have only gotten where we are right now by intelligent design by God. Now first, before I get into my argument, I would like to look respectively back to what Elizabeth said. She mentioned primordial soup. Now, before I even get into the rocks and everything like that, just want to say lightning hitting a pool of chemicals kind of sounds almost by intelligent design, does it not? The chances of that happening are almost impossible. And starting life. That could happen, of course, in labs and all of that, because it has happened already. Life has been created already. But life starting would have been much more difficult than recreating it now. So all these chemicals and these said chemicals and lightning hitting a pool of amino acids would be so unlikely. And even when you look at that, you have all of the harsh climates. It would have been so difficult for these delicate little amino acids to be created and form life, our life, everything that you see. It's just completely impossible. Now I want to talk about proteins. Again, I'm on the side of creation, arguing that we could have only gotten where we are right now by intelligent design. To say that evolution can work, it has to work on all of the levels of life, specifically the tiniest levels. These levels of life are so important because they construct our mind and body, and they basically control how we operate. Proteins are, more or less, one of the smallest building blocks of life, so evolution has to support proteins to be able to function smoothly. And like Pietro with the flagellum and everything, these are very intricate subjects, but there's nothing that can't be cleared up with a bit of explaining. To be more specific about how complicated this subject is, Charles Darwin, a naturalist, geologist, and biologist, who basically founded the theory of evolution, admitted that he hardly understood this subject with DNA and proteins and all of that. Proteins are, in short, large complex molecules made up of one or more amino acids. And while scientists today can make amino acids in labs, they are yet to make proteins just because of how complex they are. And even if they could make proteins, it wouldn't really matter because if scientists are making them, they are man-made, but evolution claims that they were made by chance. But to better understand exactly how complex these proteins are, this first number over here is the calculation of the odds of the smallest protein being created and functioning properly. There's one chance in this huge number that this protein can be created. And again, this is one of the smallest proteins, which is found in plants, and it is nothing compared to the ones found in larger species and our human bodies. To be more realistic, the average protein contains 50 to 2,000 amino acids. This is the calculation of a protein with 150 amino acids in it. Again, there's one chance in this huge number that this protein can be created and function properly. To go even farther with calculations, that is Titan. This is the largest protein with 27,000 to 32,000 amino acids composing it. And as you can see, it can't be represented like the other two, and it isn't. To do that, it would take up the entire poster and probably even more just to write out all of the digits of Titan. And again, there's one chance in that number that you can't even comprehend that Titan can be created and work properly. And it's not that rare either. It controls the elasticity in our muscles, which everyone needs to be able to move their muscles and walk around and function. You should also take into consideration that there are approximately 42 million proteins in one cell. So you would basically have to multiply all of these numbers, all of these odds, by themselves 42 million times just to get the odds of creating one simple cell, let alone an entire population and everything that you see. By all of this, you can see how astronomically low the chances are of millions of proteins being created all by themselves are, with no intelligent design, and how life beginning without intelligent design is, quite frankly, impossible. Thank you.
Okay, that is all the speakers for the moment. They are allowed a 5-minute break here just to try and gather their thoughts with the final rebuttal. So I've got like a 5-minute break if you want to stand up and stretch or anything. Absolutely, yeah, that's a good idea. Yeah, and there'll be kind of like a Q&A time at the end if they want to ask you questions, yeah.
You can't. I mean, you can say, well, every time yeah, a couple like million. That's a million right there. Yeah, you should. I just well, I do, but I just I know that, and I just don't know how to get it out. Oh, so when you like you said that. I think you should just say it again, just so that they know.
Dude, who said Mr. You had such a good picture. You went and you ripped the whole thing as that helps. Are we able to like make it? That really is okay.
I'm sorry. You can read it 1,000 years. It's just he's not someone who's a lawyer, knows what other lawyers can say or needs to say. No, you think okay, yeah. I was hoping physical fight or mental fight. Yeah, Chloe was in the paper here, and they joked.
I have everything.
Okay, guys, you have about 1 more minute.
Oh, you're here?
Yeah.
Only for the
winning team.
Hey, Zoe, don't let them bribe you.
If we did win, I would be inclined to give you like 10 cupcakes. But I would really only be inclined to do that if you won, So I suggest in a giving, I might just like throw money at everyone.
So persuasive is one. You trying to bribe me over here? Wow. Oh boy. Great. Okay, guys, we're going to get back to the debate now. So you just kind of finish the little conversations. We'll resume with the final part of the debate. Okay, for the final debate section, we have two speakers. It'll be Gerald representing the evolution team and Ian representing the other team. And this is their chance. They're not supposed to present any really new material. They can rebut other points. They can clarify. They can add small amounts of detail. But mainly is to bring up the major points that they thought was wrong with the other side and then try and convince you finally of their position on their team. So, Ian, Gerald, fix it.
Alrighty, so I'm Gerald Levesky, as you guys know, and I will be doing the rebuttal for the evolutionists. So, where to start with the creationist views? The idea of irreducible complexity in no way debunks evolution. You can think of it, well, yes, maybe with that motor, if you take one tiny piece out, it won't work. But as opposed to thinking about it that way, maybe think of it differently. Maybe think of it like the first cell couldn't move at all. Then maybe think of it as it had maybe two magnet-like things that formed by mutation that were able to push some type of rod back and forth to propel it forward. So as opposed to thinking about it as taking off one piece, you could think about it as slowly getting more complex. Again, going back to their idea of the mousetrap, the first mousetrap might have just been a man dropping a rock on a mouse. The second trap, it gets a bit more advanced. He adds a stick. So the mouse can run under it, trip the stick, and get hit by the rock. The next one, maybe he tries to spring load the rock, etc. And it keeps building up. So that's how irreducible complexity really doesn't disprove evolution. Next, with the the abiogenesis. Just because the chances are low in no way implies that it's impossible. Improbable? Maybe. Impossible? Most definitely not. Also, although those chances are ridiculously low, we have to take into account that the Earth did not produce living organisms till 700 million years after the Earth was created. Now, that is so much time for these conditions to occur. And also, just in a matter of a couple of hours, in the experiment my teammate Elizabeth was telling you about, they produced 22 amino acids in a matter of hours. Now spread that across 700 million years. That is plenty of time for everything to form. Also, she brought up the point where you would need a whole colony of organisms to start. That is actually not true. All we would need is one single organism to be created. Then it could asexually reproduce to get 2, and then they would asexually reproduce to get 4, to 8, to 16, etc. And then we wouldn't need necessarily at that point, we wouldn't need proteins like the Titan. Maybe we relied on simpler proteins that don't even still exist today. Just like the trilobites used to exist, now they don't. Maybe there were simple proteins we haven't found that were able to be created to make the building blocks of life. So the other argument they had was microbiology, which I talked on a bit when I did my rebuttal. And although we might think certain organisms are similar in some respects, and they're not, like Polly was essentially saying, oh, these look very similar, the evolutionists say they should be the same, but you're only taking into account one thing. That's like comparing maybe 2 cars together and going to their engine and the engine's being completely different. So you say, hey, these cars should be similar, but the engine's different. That's a very small part of the bigger picture. If you focus on maybe the doors or the windows or the tires, they would be similar. But in Polly's case, he chose to choose the most different variable. So that does not in any way really imply that just because of this one number, the ones that seem not similar are similar, and the ones that seem like they should be similar are not. Just because of that single variable does not imply that all the evolutionist views are wrong. Now, thus, after exploring all the possibilities of life, from abiogenesis occurring to get the first organism, that first organism changing through mutations, natural selection, to progress and evolve, and then the evidence of the fossils that illustrate the progression of complexity and diversity, we are able to see that we have certainly come a long way without God. And thus, evolution without divine intervention is the only reasonable explanation for life today.
Okay. My name is Ian Jenkins. I would like to start by thanking this team over here for producing their delightful 3D printed models and stuff. Very good job flexing over here. And I would like to thank them for presenting their points well. They did a very good job. But the problem is that they're presenting only what science can offer. And science just cannot offer up everything that you need. Again, when you look at, to start with the point of the primordial soup, which he made a very big deal out of. When you look at the actual rocks from that time, they show a very different environment, not really suited for creating these special amino acids. And these are only amino acids. These would still need to link up into the various proteins and stuff like that. Now these proteins, again, said that they were rare, and now I said that these were rare, and the very specific, really large one down here is especially rare. Now this seems like a very large number, and you probably were wondering, what's this number down here? That's the number of atoms in the universe. Number of atoms in the universe, 10 to the 82nd, so that's a 1 followed by 82 zeros. 10 to the 3,127, 1 followed by 35,127. It's a pretty big difference, and they also brought up the fact that, well, life began 2 million years after this, and that's plenty of time for life to get going and begin building itself up, working into molecules and proteins that would allow us to move around and stuff like that, but that's actually still too little time. When you look at what we actually have, and actually people have calculated this, that actually if you were to take every single life form that has ever existed, from the little tiny bacteria that began it all to all that stuff, to like even the creatures that are being born today, and you were to take into account all the possible mutations that would happen for a 150 amino acid log sequence like here, you would only get through 1/10 trillion of there. Less than 1% of the entire number right here for 150 amino acids long. That's a really small, that's like ridiculously small. And then when they brought up the fact that hypothetically we could have, like the flagellum could have evolved through things like, say, an electron thingy and like a little thing that passes electrons around to spin around a like little stick. The problem with that is that these have to be both beneficial mutations, and they would have to work together to make a moving mechanism, and these would have to be programmed into the DNA. And again, and as was talked about by my classmates over here, the chances of one of these proteins, of a beneficial mutation actually happening is 1 in 21,000, which is insanely small. And you would have to do that twice just to get that very basic, very, very, very basic that this man over here proposes. So, yeah, it's just not going to work. And then they also brought up COVID within this last year. And COVID has definitely been changing, but that's microevolution. And microevolution does not equal macroevolution. And it just does not work. It's just, you go from a small, you're talking about little tiny changes, and with these mutations, they don't add to the DNA, they take away. Mutations hardly, really, not even hardly ever, they never, not any time that we have seen mutations in the past have they taken something and added to the DNA sequence. They have instead, it's always been it's always been a mix-up of some letters. It never adds. It usually ends up destroying something that would otherwise be really, really useful to the creature. So as we have proven over here through these numbers over here, which show that there are no connections between the complexity of a creature and its DNA to creatures of similar complexity. The flagellum over here, and other reducibly complex machines, which are found in almost every cell, and through the sheer improbability of forming even the most basic of proteins that are only 44 amino acids long, we could only have gotten to where we are today through creation by God.
So that ends. I'm sorry. Was it good? I say good. I'm going to ask questions and something to discuss.
We're going to question and answer time
Yeah,
now? Okay, then that's the next stage of this. All of you who are gathered and, you know, either officially or unofficially judging our students up here. If you have questions, you'd like to see if they actually mastered their information or only mastered their presentations, now you can ask those questions.
First of all, is there anything else, after you're done with this now, are there things that you were timed, I know your nerves were kind of on edge, are there final things you want to say that's just kind of little things you say, oh, I wish I'd said that, or something else that really stood out to you?
Yes, in terms of the rebutting, Matteo brought up the line of the Homo sapiens and like their various ancestors. He didn't bring up the one that's most commonly cited, which is Lucy, Australopithecus. The reason why he didn't do that is because there is a lot of dispute among the scientific community because they have found many different fragments of this creature's bones, and they all seem to be very different. And scientists can't agree upon whether it is simply the fact that the males are different from the females, or whether it's just two different human ancestors that have lived in the same area. And actually, even just a few years ago, back in 2015, they found out that one of the bones that had been in Lucy's skeleton for a long time was actually a baboon bone that got mixed in with a bunch.
We have a question back here.
Yeah, from Mr. Gerald Investy. In your example of the bolt of light hitting the amino acids, producing a protein, can that be reproduced in a lab?
Yes, it was reproduced twice in the 1960s by the Miller and Urey experiment, and again in 2008 at Berkeley University.
Wonderful, thank you.
And
Can I follow up?
we've got
I just
response
wanted to
and then
clarify.
over
Did they create amino acids or proteins?
They created amino acids.
Okay.
Which are the building blocks for proteins, and given 700 million years for them to sit around for, very likely they could link up.
Still would have to reproduce.
Okay, and then over here.
Just follow-up question to that. When they did create those amino acids, how long were they able to sustain, and did they have to do anything to keep them, or did they just fade out immediately? Did time help that, or did time hurt that?
I am not aware of information pertaining to that. So.
The amino acids, they're not really like life forms, so they don't really die. They're more so like a natural material, so they wouldn't really have worn down over time.
And to briefly explain something that the creationist team overlooked, one thing you have to keep in mind is that even though we were not able to immediately create proteins, we simply haven't been working on this for a long time. The study of genetics is a very new study, and also, even, it'd be like you learn the recipe for how to make bread. Even if you get everything together and you have all the ingredients, you still need to wait for the bread to rise. You need to allow time for this. So given enough time, it might have indeed made a protein.
And in this case, it would have taken the bread 700 million years to rise, which for obvious reasons we can't really wait around that long.
Yeah, so on the creation side, you guys did a really excellent job of discussing in length why evolution didn't happen and why there are kind of holes in these different theories, but obviously, like, coming up with an explanation for life is like a really big feat. Even though, like, Stephen Hawking's like brilliant guy, but like he probably knows that much about the universe, right? It's just something that's so vast, and like we're talking about things that occurred over a billion year timeline. So I understand that some of the kind of ideas and conclusions that we're drawing from empirical evidence aren't working for you, but what do you propose then did happen? Because I'm hearing a lot of like this is what didn't happen and why. So I'm just curious then, what do you suggest happened?
We don't really propose how life itself started in a natural way. We propose that God made life the way he made life.
Right, so like what does that look like?
We don't really have a proposition for that. We don't really...
Well, I don't know.
In their defense, there are no first-hand accounts of that time. It's not like we're trying to recount the Crusades where we have first-hand accounts and stories about it. We have the creation story, which was passed down orally, but that is all they can really cite for evidence.
Yeah, but we also have a problem with your thing, because all of this is taking place in the unforeseeable past. Like, you can't really observe the past. You can't recreate the past, really. So really, it's not science versus faith. It's an interpretation of what we can observe versus an interpretation of what the other people observe.
Are you talking about that we couldn't figure out what the Earth was like 3.9 billion years ago?
Not at all. I'm just talking in general. I'm saying that everything that you say is just interpreting what can be observed. And we do the same thing.
But it is properly observed. I actually was able to make a program that approximately calculated the amount of, I think, radium back at the beginning of the Earth. And because essentially the way these isotopes work is every given amount of time, it ranges from literally seconds to billions of years, they divide in half.
Yeah, the half-life.
Yeah, the half-life. So if we know the decay rate, you can kind of work backwards. So let's say radium's decay rate is a year, which it's not, and let's say there's only 1 gram around today. Then we know a year ago, there were 2 grams of it. 2 years ago, there were 4 grams of it. 3 years ago, 8 grams. 4 years, 16 grams, et cetera, et cetera. Yep. So by doing that, it's a really efficient method, because it's not really like, oh, it'll divide in half about every year or so. Like, it's very exact. It follows the rules to a T. It's not like, oh, yeah, every year it'll divide kind of close to a half. It's exact. So we do, by using these methods, know exactly what the Earth was like when life was created. And that's how we were able to recreate it incredibly accurately.
I hear you. My issue with the radiation argument is that with the radiation, it would have to be concentrated enough that it would, in fact, cause these simple life forms to mutate and change their DNA, but it would also have to not be radioactive enough that it just, like, the photon hits the creature, dies.
Well, we're not technically speaking about, we're more speaking about how the radiation could have caused amino acids as opposed to how it could have caused mutations. More so.
And going back to what you said before about the fact that it's just us interpreting the data and you interpreting the data, that is all that science is. Science is the interpretation of observable data, and we can observe evolution occurring. Yes, we cannot see macroevolution occurring, perhaps just because there hasn't been a catalyst that has allowed a large amount of evolution to occur.
So that raises a question for me. One of the things that was interesting when you talked about, when you were posed with the question of would you believe in punctuated equilibrium, are you proponent for that or for neo-Darwinism? You said neither. What is your standpoint from your team then if it's not either one? Because there's the two observable, like what the two major beliefs are. So what was your proposal?
We stand somewhere in the middle. I personally stand more towards the argument of punctuated equilibrium. I believe that it's far more likely that creatures would have rapid development, which would explain something like the Cambrian explosion. You would have a buildup of mutations and then a catalyst which allows them all to be revealed. I do not know what the rest of it is.
So what about the rest of you?
Well, yeah, I guess I would say I'm kind of more like a classic Darwinian evolutionist.
So you're Darwinism.
Yeah, I would
Classic,
say
so.
I would say the same thing too, to be honest.
In terms of classic,
Neo?
the classic neo-Darwinism
Yeah.
then? Okay. You're saying classic or neo-Darwinism? Which way are you? The neo-Darwinism? Okay.
So, yeah. The only problem with punctuated equilibrium is I will say that does explain why when you look at the fossil record, it doesn't really show transitional links. The only problem is it's already taking a rather short time frame for creatures to evolve and just shortening it by like a lot.
And if you're in your favor of neo-Darwinism, then what about, since Gerald, you talked about the fossil record, what's the one major problem neo-Darwinists face is that with the fossil record doesn't back up neo-Darwinism because you're not seeing this slow variation of species that they propose. What the fossil record seems to indicate are much more drastic changes, which is why I know a lot of scientists have gone in the direction of punctuated equilibrium.
I would like to go back to what Ian said back in his speech, is that you could take every single mutation that we estimate has occurred over all that time, and even all of those would not be enough to take us from a single-celled organism to fully complex life like we see today. But taking into account the fact that radioactive isotopes would likely have been more common, like Gerald proposed, we likely would have had mutations being more common the further back you go.
Fair enough. The only problem is, again, most mutations cause things like, your blood doesn't work, or you won't or like using the example of like some sort of molecular machine like the flagellum, say maybe this ring down here won't form or something like that. Most mutations function something like that and not.
But given that there's so many mutations, you say most, but not all. So there is still room for maybe a flagellum to have an extra thing like on the tip of it that happens to make it go faster. That cell is able to go faster, it's able to outrun its predators, it's able to survive better. And thus it passes that mutation on to its next offspring. That offspring might have another mutation where it makes that little thing on the ends of the flagellum like longer maybe. And then it just makes it more efficient at traveling and escaping its predators. So even if the chances were very unlikely to have good mutations, given all the mutations that would have been occurring, it is very possible that many of them were good.
But then again, most of the stuff that you guys have brought up in whenever rebuttaling any of the things that we said, it's they might have been this or they might have been that. Like we have this right here. This is the largest number right here is for each like person. Like that's there's no way that just happens. Oh, it might have been for this person, that person. It might have. It's just so.
Yeah, the question is that yeah, it's technically possible, but is it really likely that we would have gotten to where we are now?
I would argue
number that is way larger than the number of atoms in the universe.
It's universally large.
I would argue that you guys do the same thing to some extent, where you're essentially saying, well, God might have created the first life. He might have, brought all the mass in. Because I mean,
yeah, we didn't say that though.
But again, that's really not, you're kind of doing the same things we would be doing.
And one thing to keep in mind is that even if you do less of that, you guys have had a lot more time. Creationists as a whole have had a lot more time to come up with arguments against what we propose because the study of genetics is such a recent study.
Well, then again, the study of anything online, if you check it out, we've had a harder time to research our stuff because most of the stuff that you guys researched are easier to find than ours. I mean, that's a whole different subject, but again, ours is a lot harder to figure out. So we didn't, us as a group right now, we didn't have more time to research this stuff. It's
But
actually a lot
the
harder.
thing is that, Gregor Mendel didn't even come up with a vague concept of dominant and recessive genes until within the last several hundred years. We didn't have Darwinian evolution until about 200 years ago. We simply just have not had the time to come up with arguments. You have all had, the whole creationist side has had thousands and thousands of years to build up explanations for everything that we see in the world because not only is it what they believe, it's also the foundation of everything they believe in. It's the way they view their world. We simply believe that this is something to be studied. This is their lives.
With what you just said, with how that's just what you study, this is our lives. Isn't that the truth, though? That's kind of like your lives, too.
It depends on who you ask.
Got a
Also-
question back here?
May I briefly finish what I was going to say?
Finish yourself up,
That for around 1,000 years, creationists have had, and for much longer before that, people who believed in divine creation of some variety, maybe not specifically the Jewish variety, but of some variety, have had no opponents or no vocal opponents.
Yeah. Also, with bringing up that it's such a recent thing, it's because most people got into you've seen that technology's gotten broader and broader, and that's when you pointed out there, that's when evolutionists started to flock in. They started looking at the science because people for years just laid back. They didn't really because they weren't not as smart, but
they didn't have
they didn't have access to the same things. So when it started with evolution, people started believing the evolutionists, and
they saw basically just a little green glob.
Exactly, and so no one tried to dig into creationism, and so then you have a whole year where you're actually in head, and then we're also behind. So again, also harder for us to do our research.
Yes, but still you had thousands of years to formulate arguments over things that we've still only had about 200 years to argue. We still just have not had the amount of time, even if it is something that a lot of people devote research to.
And I think one of the reasons that evolution, at first it was to the dismay of a lot of, creationists when evolution was brought up by Darwin. But over the years, it's really the core thing that almost everyone believes. I'd say well over 90% probably. And I think the reason for that is because the creation ideals are based not really off of facts, more of vague assumptions and, you know.
And it appeals to the emotional side of humanity where
Exactly.
we need somebody to rely on to say, in some cases, this is your fault.
And that's why I think so many people flock to evolution, because you have the facts, you have the explanation.
Yeah, we don't rely
I
on
just-
See, I think
like
it's
some
kind
kind
of
of
the opposite. I think
emotional
that
tie
kind of-
to something.
What?
We don't believe
I'd just
in
like to
some
say,
fault.
Elizabeth, you mentioned that it was basically a crutch, right?
Yes.
Well, that doesn't mean that it's not true. When you were little, or still now, your parents are crutches, are they not? You rely on them to get the things that you need to be healthy and be okay. Are they not true? Are they not real?
They
Do
are
they not
real,
exist?
but they cannot stay forever. They cannot forever be a crutch. Crutches are a temporary thing. Yes, if you need a faith to get through your childhood, that makes sense, but is it really following the logic that you gain as you get older?
Before we continue with this argument, I'm
To
sorry.
go back,
someone
somebody had a question, I was just gonna
Yeah, I was
say,
gonna
the
say,
question
somebody
back
else.
there.
I was about to say,
Oh, I was just wondering, and my question comes from a place of immense ignorance and just curiosity. I know, like, I don't know much about creationism at all. I was wondering kind of where creationists stand as far as the, like, empirical data, because, like, I mean, I'm sure, like, you guys have seen, like, fossils in person, you know, and, like, carbon dating is hard to compete with. So, like, so I guess first, kind of where do we stand on that, and then what happened? Like, there obviously were a lot of species that are no longer. What happened to them, and why? I guess from a theological perspective, why would God create something just for it to die out? And then, are we still progressing? Like, if we're not acknowledging these slight and gradual progressions over the timeline of Darwinistic evolution, and we're making these jumps, then is there going to be like another species like that, like, appears one day? And why would God create something with, like, absent of the intention to progress and grow into something better and stronger?
I feel like that is a question best answered by the man in the back.
Yeah, that's a question to you.
The man with the collar.
And actually, the one thing I do want to say, I think you guys need to delineate also the difference between creationism and intelligent design, because you're kind of, by being on the negative team, you didn't have to state your position strongly,
Yeah.
but most of the research you presented was intelligent design, which is science. It's actually a science, as opposed to creationism, which is the religious movement that goes,
Yeah.
that kind of backs it or
Yeah,
is
exactly.
related to it.
Yeah.
So if you can explain that, I think it might just help
So
to
the difference
explain it
between
to
intelligent design and creationism?
Yeah.
Okay, so creationism is basically the belief that God, big G, created, that he created everything as it was meant to be. Intelligent design is more looking at the empirical data that we have. So, like, by looking at things like the diagram of the flagellum, and you see all the different parts that are there, and it's like, that's a proper motor. That's not something that that's not something that can just happen. That's something that's properly designed. It's looking at what is out there and seeing that it's just not really possible for it to have, like, just come into being. It's not really possible. It's like, I'm trying to figure out how else I should
Explain it, that's a branch of science, though, that's not
it's
actually.
a branch of, ultimately it's a branch of science, it's not faith, it's just recognizing the fact that this stuff is so complex we couldn't have gotten to here without some sort of intelligent design.
Well, just because it's complex and difficult to understand doesn't mean we have to chalk it up to a magic guy in the sky to explain it.
That's not what some people say. Most of them are actually much less logical than that.
Also, with your theological question, I'm going to try to explain it. Well, because God, it says that, God is, we are made in God's image, and we are the ones, humans, are the ones that are supposed to progress forward. So if an animal dies, like the Jews used to sacrifice lambs and stuff to God, and like when you read the Bible, you can see a lot of animals were sacrificed to God. And so if these little animals, if they progress and die off, then it doesn't matter, because in the end, it's for us as humans to go to heaven, to be there with him. And so that's kind of what my thoughts on your theological
Yeah,
question.
and getting back to like the more scientific side of the whole, but also kind of staying in the realm of theology, we sort of actually like see evidence of the fall through what's called entropy. It's basically this statement that things will slowly devolve into chaos, and that's kind of what we're seeing actually with our own DNA. With like every generation, there's like about 100 mutations that are passed on, and that keeps stacking up to the fact that we're not actually evolving; we're more devolving.
Excuse me. I would like to pose a question to your team. You said before that
Wait, before you go on, I want to offer to the group here. I'm staying conspicuously silent in this because I am the theologian in the room, but also because this discussion they're having was part of my own journey to faith 25 years ago. So I have a lot more detail in some of this area, and I've trained in it. If we want to have a follow-up discussion about this, I'll be happy to get into some areas where I think both teams misunderstood pieces of the data.
That would be awesome.
As best as I understand it. But that's for later, not for today. So go ahead and ask your question.
I just wanted to ask, you said that in the creationist perspective, God created all creatures as they were supposed to be. So why then would microevolution be a mechanism? Was that simply a misphrasing, or was it actually an error?
Well,
And does your team as a whole believe in the concept of microevolution?
We do believe in microevolution. That's something that you can actually, that's like truly, like, we call evolution, we call macroevolution not really a science because you can't observe it, but microevolution is an observable science. You can see it in things like dogs, with like how you could take something like a wolf and over a bunch of generations you can breed it into something like a chihuahua.
Right, and I think, Elizabeth, also, you said, like, if we are made to be how we are, then why would we evolve even just microevolution? But as everything around us advances with, everything, climate change and volcanoes, everything like that, we have to advance with it.
Basically,
to
human beings are
survive.
made to adapt.
Of course. Or else we would not survive and completely die off in general.
But why would we have like the diversification of species even now? Like we have people who breed dogs, and then you get various different breeds.
That's just
They're bred for selective reasons. So,
Right.
so like a dog may be bred to go after rabbits. Another one may be breeded so that it guards sheep. Another one to pull sleds, stuff like that.
But if all creatures are created, like if all men are created equal as our Constitution, as the Declaration of Independence says. My brain is not working. I can't remember which document it was for some reason. It's been too long since I studied American history.
I think it was the Constitution.
Yeah, you're right. It is the Constitution. If all men are indeed created equal, then why do some people have advantages over others? Why are some people stronger, some are weaker? Why do things like harmful mutations occur? Shouldn't all things be to our betterment?
Again, evidence of the fall and entropy, the natural degradation of energy and things and information. And one other thing that we have a question for you about is, if everything evolved from one creature, and say like it's commonly accepted that like some sort of fish thing came out of the water and it was the first thing to crawl on land, right? Is that what's still believed, Gerald?
Well, the first organism wouldn't have been that fish. The first organism.
No, we just mean like what was the first thing to like walk on land? Like the first thing to like.
Oh yeah, it's believed that it would have been a fish-like being.
Okay, so what I find most confusing actually is that you brought up why would we have the diversification of species, but that's the same question that we can ask you. Like, what would be the benefit of having one creature that can soar in the sky but can't really swim all that well? Like, what's the
So are you
advantage of
saying
that?
basically why don't all creatures have the same evolutionary advantages and just progress from there? Like shouldn't we all have like wings and gills so that we can fly and swim as well?
Yeah, pretty much, exactly.
Well, I think that ties into more of the the like requirements for everything, like certain animals, like worms, their excrement is used to help like grow other things like that.
Yeah, creatures would adapt to live in harmony with each other, and
The
that would
like,
include
what's
things
it
like
called?
being able
Design.
The like bio.
That sounds more like intelligently created so that like this thing does this so that this other thing can do its things that the other thing can do its thing.
Well, okay, what about something, okay, say for instance you have one omnivorous creature. They all are eating everything, but then eventually some creatures have a tendency to eat more meat, and then some creatures have a tendency to eat more plant-based objects. And basically they would divert from there, and certain creatures would only eat meat, some creatures would only eat non-meats.
Okay, so with that, I lost my train of thought.
Here, I think I can say something. Well, like, say you have a group of lions, and there are deer and gazelle and everything that they can eat. What happens if the gazelle stop reproducing and there's not enough for the lions to eat? They might start eating some plants and stuff like that so they can survive, because I would imagine animals know that if they don't eat, they will starve.
Mm-hmm. That's what I'm proposing, is that it would start at, like, you know, if you were to have, say, an entirely carnivorous society that then could not get enough meat, some of them would become herbivorous, so that you would have enough for both sets of creatures to survive.
But I have a question. What if it's more advantageous to be able to eat both plants and meat? You gave the example of something like diverting from an omnivore. Why would they ever divert from the omnivore if choosing their separate paths only allows them to eat one type of thing?
Yeah. Well, through my extensive knowledge of African biology, I believe what occurs is the lion form in hunting groups and hunt and eat wildebeests, and then over time the lions degrade from old age and die, and then from that they create fertile soil in the ground, which then is home to many plants, which then is eaten by the wildebeest.
All right, I think we're out of time, guys. Sorry, but thank you for your time. You guys give me a round of applause. You guys did a great job. You're done. You can relax.
It's like the over. I'm trying to remember what it's called. I think it's called the Oval of Existence. Oh my God.
I think
I'll say it.
I think it's the square of the Oval of Existence. That sounds like some sort of like Disney knockoff thing. It's like, it's not the circle.
I'll total it up. I'm just gonna look at all the comments. So you remember that? I'll take all your comments, everything like that. No, you don't. I mean, like all of your marks. I mean, I'll take those. Thank you.
I thought the question was never end.
I know. Just to never again. To never doing that ever again.
Joe Cunningham. I'm Gerald's grandfather.
Oh, it's very nice to meet you.
You know, I had a great idea. Since like the whole Easter thing happened, for like a
I'm not sure yet. That's I should ask the crowd what they thought.
Good job, buddy. Good job.
Good job.
Such an analysis of what happened.
Great job,
I love it.
Oh, thank you. I'm so glad you enjoyed it. Well, I just wanted you to get such a note. I like that they're all trying to figure this out for themselves. They all material and know how to do it.
But just the fact